بسم الله الرحمن الرحيم. Today we will start the last section of Unit 6, which is modeling of any general finite state machine, which is and another name for synchronous sequential circuit. Now we have already covered some synchronous sequential circuits like the counters and register. All of these are synchronous sequential circuits. Since you will be using flip-flops and the clock, that means you're working on a sequential circuit. ولكن الكاونترز والregisters هذه كانت يعني special cases of sequential circuits, and the way we implemented them it's going to be a little bit different than modeling any general sequential circuit. You can implement counters and register using the material that we will cover in this section, ولكن يعني it's easier to cover them or to implement them using the methods that we covered in the previous lectures. We will start with a general يعني overview on sequential circuits. So we have two types of logic circuits. We know combinational circuit, and يعني as a definition for a combinational circuit, you have a block of logic that will have a number of inputs and a number of outputs, where the output directly depend on the input. Any change in the input can cause a change in the output directly. تمام. And we model this إذا بنتكلم عن behavioral modeling in Verilog, we use an always statement, and in the sensitivity list we list all the inputs of this circuit. So any change in the input will go inside your always block and will execute whatever equations you have here. تمام. بالنسبة للsequential circuit, so the value of the output of a sequential circuit will depend on two things. Will depend on the value of the input, just like any combinational circuit, plus the past behavior of the circuit, which we call the present state of the circuit. So a sequential circuit will have a set of states. This is what we see in a state diagram. الستيت diagram بيوضح لنا ال present value of the input and what state we are in. And in terms of Verilog, we used an always block, ولكن in the sensitivity list we use either positive or negative edge for a clock signal. So whenever this edge comes, سواء كانت positive or negative, we go into our always block and execute the statements that we have in here. So the changes in the inputs for a sequential circuit will not directly cause a change in the output. لا, we depend on the clock. Every positive edge or negative edge, we check the values of the present state and for the input, and then we execute whatever functions we have. Now for sequential circuit, there are two types of sequential circuit. There are the synchronous sequential circuit and asynchronous sequential circuit. We will only cover the synchronous sequential circuit. Meaning of synchronous, we know that it depends on a clock signal. Any change in the circuit will be depending on the clock. أما الاسynchronous لا, it does not depend on the clock. طبعا asynchronous sequential circuit will also have flip-flops and latches. There are ways to design them. They are much harder to design, and it's not covered in this course, and I think not any course that I know of in this program. تمام. ولكن asynchronous circuit لها ميزة إنها in terms of speed it will compute your values much faster than a synchronous sequential circuit. Okay. ولكن you need to know, okay, you need to know that there are two types, and you need to know the definition of each one of them. Synchronous follows a clock. Asynchronous does not follow a clock. It doesn't mean that asynchronous is a combinational circuit. Don't get confused between the two. Combinational circuit ما في يعني you will not use any storage element اللي هو latches and flip-flops. تمام. ف sequential circuit have two types. one that follows a clock and one that does not follow a clock, اللي هي synchronous والasynchronous. Also don't get confused between synchronous reset and asynchronous reset. تمام. هذه types of sequential circuits. So in terms of definition you need to know that. طيب بالنسبة للجنرال form of a sequential circuit أو a form of synchronous sequential circuit, first you will have a clock signal that is routed to all of your storage elements. In this case we have flip-flops, but you can also do synchronous sequential circuit using latches. Also we're not covering that. ولكن you will have a set of flip-flops that is controlled by a clock, and it will have a set of inputs coming from a combinational circuit and a set of outputs going into other combinational circuit. طبعا مو شرط انه الاوتبوت is going to a different combinational circuit. There is يعني another way to look at it, اللي هو اذا كان عندك combinational circuit block here, there's a combinational circuit, you have a set of inputs and a set of outputs, and you will have storage elements, in this case flip-flops. Some of these can come into input of the flip-flops, which is called the next state, and then the output of the flip-flop is the present state or current state. So this is being fed back to the same combinational block that you had before. From the input and the present state, you can determine the output and the next state equation. And from that, we have two types of sequential circuits. We have something called a Moore type sequential circuit or Moore machine, and we have something called a Mealy machine. الفرق بين المور والميلي, it all depends on the output. أو it's talking about the output. تمام. المور machine, the output of the circuit depends only on the current state. So if the output depends only on the present state, then this is a Moore type sequential circuit. However, if the output depends on both present state and the inputs, then this circuit is a Mealy type sequential circuit. To look at it from the same diagram that we had before. So if this is the output, just let me write an example. Now, let's say you have this circuit عندي a number of inputs, عندي flip-flops, هذه next state equation going input for the flip-flops, and the present state here is also being fed to the same combinational circuit. الآن if your output is coming from here, let's say Z is an output of your circuit, this is a Moore type sequential circuit. Why? Because the output depends only on the present state. تمام. The input here is only used to find the next state equation. So the input will go into the combinational circuit. Along with the present state, we get the next state. لكن the output of the circuit only depends on present state. This is a Moore machine. If you have a sequential circuit that looks like this, I have a flip-flop. It's going to be the same in the input, some number of input, and the next state equation going into the flip-flop, and this will give me the present state. Now, if you have like a couple of signals coming from the present state, and one of these signals depend on the input directly, now this is a Mealy type machine. Why? Because Z, which is the output of your circuit, depends on the current state plus the input. Okay, so if the output is a function of present state, this is a more type machine. If the output is a function of the present state plus uh, the inputs of your sequential circuit, this is a Mealy type machine. And both of these will become obvious when you check the state diagram. You can tell directly if this is a Mealy or a Moore machine. Okay. Now we'll take an example. Actually, in this section, we only have two examples to cover. Just to give you a general form of writing any finite state machine. So we'll take an example of a Moore machine. So let's read this example. Given the following sequence of inputs and outputs signal, we have an input called W and we have an output called Z. The circuit has one input W and one output Z. Changes occur on the positive edge of the clock signal. This is very important to note because this is going to determine what goes into your sensitivity list. The output Z is equal to 1 if during two immediately preceding clock cycles, the input W was equal to 1. Otherwise, the value of Z equal to 0. If you remember from 211, we implemented so many of these sequence analyzer. أو كان اسمها sequence detector. This is the same question. I want to detect the sequence 1 1. So if you take a look at this example, now this is clock cycle T0, T1 up to T10. This is my input W that is coming to my circuit, and this is the output Z. So notice that Z will become 1 only if the last two cycle I had two ones next to each other. Let's say W goes 1 at T6 and then goes 1 at T7. That means the next cycle Z should be 1. Now also notice that T8 is also 1. So Z will stay 1 because the last two cycles from T9 was also two ones. تمام؟ اللي كنا نسميها overlapping sequence. So if I get 0 0 1 1 0 1 1 1 1 1 0 مثلا, now the output for this sequence should become here 0 0 0 0. Now I have two ones, so this cycle Z has to go to 1. And then 0 will break the cycle, so we'll go back to 0 for Z. And then I have only 1. This is the second, so here Z will go to 1. Next cycle will also be 1 because we have two ones here. And then the next cycle will also be 1 because I have two ones in here. Okay, after that it will become 0. So this is just an example of a set of input and what should happen at the output. ولكن for the question, from this description, you should be able to know what's the requirement of the circuit. So basically, it's saying design a sequence detector that will detect the sequence 1 1 and will allow overlapping. Okay, so for any sequential circuit design, we will revert back to whatever we studied in 211. You'll start by creating your state diagram. State diagram will contain a description of your the behavior of the circuit. So we start with state diagram. طبعا, how to come up with the state diagram? After you read the problem description, you should be able to draw the state diagram. So you create the state diagram, and then from that you create the state table. After the state table, you should determine the number of flip-flops you need and the state codes. Each state should have a code in binary. طبعا states, for example, here I have state A, state B, and state C. Since you have three states, you need to determine the number of the flip-flops by using log 2 of the number of states. طبعا the ceiling of that. So log 2 of 3 should become 2. So you need two flip-flops. Two flip-flops meaning each state will have 2 bits to represent the state. And then you give it a code. مثلا تعطي A 00, تعطي B 01, C you give it 11 or 10. It doesn't matter. After you come up with the number of flip-flops and the state codes, you already created the state table, and then you have to create the key maps for your output and your next state equations. From these key map, you're going to get a function for the output and function for each next state. And then draw the circuit. Here is where we stopped at 211. Now there will be one extra step, which is write the Verilog code to model the circuit. Okay, so these are the general steps for designing any state machine, any finite state machine. Okay, so let's come back to our example. We'll start with state A. This is the state where when you reset, the circuit will go to. So at reset, or reset N, which means this is an active low reset, we will go to state A. State A اللي هو initial state. So at state A, the output Z will equal to 0 when you reset. And then depending on the value of W, so if W equals 0, stay at the same state, which means nothing happened, like there is no part of the sequence was detected. Now when W gets to 1, so you have 1, 1 in your sequence. So you go to state B. In state B, you still have the output is 0 because we have not detected the sequence yet, because the sequence is 1, 1. Now from state B, if you get another 1 from the input, you go to the last state, which is C. Here I will output Z equal to 1. Okay, meaning I got 1 from here and another 1 from there. So that means I have two ones next to each other. I'll make the output Z equal to 1. Notice that any 0 that you get in this sequence, you go back to the initial state. So from state B, if you get 0, you go back to A. From state C, if you get 0, you go back to the initial state. And if you are in this initial state and you get 0, you have to stay at this state. Okay. To detect overlapping sequences, if you are at, like, if you get 3 ones next to each other, now the output Z here will be 0, here it will be 0. Now the next cycle it will be 1 because I have 2 ones here. And then the next cycle, Z should also be 1 because I have these 2 ones next to each other. Okay, so to achieve that in your state diagram, whenever you reach state C, you will stay at state C as long as W equal to 1. So your output will keep, the value of Z will be 1 unless you break the cycle with an input of 0. Okay. I think we used to draw that in 211 as the first state was no sequence. And then when you get 1, which is the value of W, you go to the state where you have 1 in here. And then if you get another 1, you go to the state 1, 1. And now you're going to stay here as long as you get the input 1. Now the output here will be 1, here it's going to be 0, and here it will be 0. Okay. and any zero for the input will get you back to no sequence because you're breaking this sequence. So that's 0, and you stay here at 0. And since you have only one input, make sure that there are two arrows going out of any state. Okay, since you have one input, which is W, there should be two arrows going out of any state. I have three states here. Each state should have two arrows going out. One for, and this arrow is going out of state A with W0, and the other going out of state A with W1. Same for state B. One arrow will go out with W0, and one arrow will go out with W1. State C, one arrow going out for W1 and one for W0. Okay, make sure you're counting the arrows going out of the state, not in. لأنه going into the state هذه تفرق، يعني ممكن تكون 3 arrows 4 arrows but for if you want going out of this state you should have 2 to the number of inputs. Let's say for example you have two inputs. Let's say I have W1 and W0, two inputs of a sequential circuit. So any state, if you have three states in your circuit and you have two inputs, I should have 4 arrows going out of these states. فإذا عندي 3 states A, B, C, I should get an arrow for 0, 0, I should get an arrow for 0, 1, I should get an arrow for 1, 0, and an arrow for 1, 1. Same for state B. State B should have also 4 arrows going out for each combination of the input. And same applies for C. Okay, this will be helpful to check your state diagram after you create it to make sure that you're not missing any cases.
طيب دكتور،
تفضل.
يمدي أختصرها يعني بأرو واحد بس أحط إن الحالات فيها؟
حسب if this is applicable. مثلا in this example هنا عندك at 0 0 and 0 1 you went to state B صحيح؟
إيه.
ف you can draw it as like this 0 0 or 0 1. طبعا هذا slash معناها output ف you should write it in another way, maybe 0 0 comma 0 1
أور هي دبل أور تكون.
او or صحيح او or تقدر تختصرها في سهم واحد، بس اهم شيء انك you cover all the cases. يعني by looking at the state diagram I should know each combination of the input which state is going to take me to. Okay. هذه اذا كانت 2 inputs يعني. طبعا 3 inputs will mean 8 arrows going out which is too much. That's another story. طيب, so coming back to our example, now this is the state diagram. From the state diagram we need to create the state table. State table, I have 3 components. I'll have the present state, the next state, and the output. So the present state, I have only 3 states, so I list them A, B, and C. And then from looking at the state diagram, you will fill these values. And for the next state depends on the input. فحيكون عندي 2 column here, one for W equals 0 and one for W equal 1. Now if I'm at state A, which is the initial state, if W equals 0, I will stay at A. And if W equal 1, I go to state B. If I'm at B, if I get 0, I go back to state A. If I get 1, I go to state C. State C, if I get 0, I go back to A. And if I get 1, I go to C. If these are side by side, it's going to be easy to see. Okay. طيب, the value of Z. And since the value of Z does not depend on the input, I'll have only one column at Z here. Z will depend on the current state. So if this is a Moore machine, this value will depend on this state. I don't need to read anything here. Come back to the state diagram. If I'm at A, Z equals 0. If I'm at B, Z equals 0. I'm at C, Z equal to 1. All these arrows does not matter for my output. For when you fill the state table, you look at the current state, match it with the state diagram, and fill these values. طبعا Z will be 0 at state A and state B. It will only be 1 at state C. Now, if this was created as a mealy machine, the table will look like this. هيكون عندي present state. I have next state. طبعا next state always depend on the input. هذه ما فيها مفر يعني. هنا W equals 0, W equal 1. تمام. And this is the output. Now, for a mealy machine, the output depends on the input. So the output will also have two columns, one for W equals 0 and one for W equal 1. So in determining the output, I should check what's my current state, and I need to check what's the value of the input to determine the value of the output. Okay, هذا حيكون الميلي type sequential circuit أو mealy machine. Okay, these two are constant. هذه in any state table that's going to be the same, because the next state always depend on present state and the input. هذا next state. الاوتبوت هو اللي يحدد if this is a mealy machine or a more type machine. Okay, now after you fill the state table, you need to give binary codes for the states, and first you need to determine the number of flip-flops you need. As we said, you're going to use the ceiling of log2 of the number of states. In our case, that's 3. So this will give me 2. So at least I need 2 flip-flops. You can create it with 3 flip-flops if you want. ولكن this is the minimum number of flip-flops to implement your circuit. You can use more, ولكن 2 is the minimum. Now 2 flip-flops, give each flip-flop a code. In this example, it gave it Y2 and Y1. You can use Y1 and Y0 if you want, ولكن يعني most problems in the book are using يعني the numbering system is a little bit different. They don't start from 0, they start from 1. I don't know why. ولكن anyways, I'll have 2 flip-flops. One will be Y2 and one will be named Y1. And I need to fix my table to wait. Yeah, so this is, we already talked about that. Now, you need to give codes for each of these states. So for state A, I replace all the A's in my state table here to the code of A. فقبل تكتب إنه A, I'll give it the code 00, B, I'll give it the code 01, and C, I'll give it the code 10. Now here, this is going to be the value of Y2, and this will be the value of Y1. Okay, so each bit of your state representation is going to be represented by a flip-flop. طيب, الآن if you have 2 flip-flops, how many states can you represent? Y2, Y1, how many states I can represent, شباب? Come on. يا اخوان عندي 2 bit, how many values I get from 2 bit?
4.
4 يا شباب تكلموا. 4 0 0 0 1 1 0 and 1 1. Okay, so I only use 3 of those. أنا عندي 3 states only. I have A, B, and C. So I have one extra combination that I'm not gonna use. So anything that you won't be using, you can make it don't cares. So it makes your K-map simplify better. So come back to this table. الآن state A has been changed to 0 0. State B has been changed to 0 1. So each B in your state table will change to 0, 1, and then state C is 1, 0. Now state 1, 1, which will not be used لأنه there is no assignment here. تمام. I can make it don't cares. طبعا D معناه don't care. But in these slides they don't use X for that لأنه X means unknown. Unknown يعني 0 1 أو maybe either it's floating or not connected. الفلوتنج Z طبعا بس في not connected is X. تمام. فدي معناه 0 or 1. Anyways, so D means don't care in this case. تمام. And we will see how this will make our K-map يعني simpler than if you fixed values for those. Then anyway, this state, you'll never reach the state in your circuit. You'll never have a state 1, 1. تمام. فI'll place it as don't care, so my K-map will simplify better this case. طيب. Now you make your K-maps from this state table. Let's take one example of that. Now, how many K-maps I should make? This circuit, how many outputs I have in this circuit?
1.
3.
3. I have Z, and I have the outputs of the flip-flops اللي هي next state. Sorry, the present state. Next state. معلش, the next state. So I need to get Z plus the next state equation. So I need to make 3 K-maps, 1 K-map for each output.
بس
Now
ما
let's
هو
make
الاوتبوت نسوي إذا كان 1 ولا كل الحالات؟
الاوتبوت اذا كان 1 ما فهمت.
يعني الكيماب نسوي إذا كان القيمة 1 ولا حتى إذا كان 0 نسوي الكيماب؟
ما يفرق. انت الكيماب هذه ما فهمت سؤالك صراحه، بس انه for any combination of inputs you should get او for any output you should get a K-map.
اوكي.
الان عندك 3 inputs. You have the input W and the input which is the present state. تمام. فعندي small y is going to be the present state, capital Y is going to be the next state. So capital Y is an output and small y is an input. If you look at the flip-flop and the input D and output Q, this will be my small y and this will be my capital Y. Okay. No, it's the other way around actually. So this is the present state. So present state is going to be small y. The next state here, that's going to be the capital Y. Okay. This is an input to your circuit. This is an output of your circuit. Okay, that might be confusing, ولكن we should clear this thing up. Now let's do Z because it's the easiest of all. Z is obviously an output, so let's do that. And I have 3 input. I have W, and I have the current state, which is Y2 and Y1. So the size of your K-map is going to be a 3 variable K-map. So I'll have the value of Y2, Y1, and the value of W. Or let's make it يعني عشان let's see W, Y2, Y1. So let's match what they have in the slides. I mean, you can do whatever you want, ولكن we try to match those. So I have W and Y2, Y1. Zero one, 0 0, 0 1, 1 1, and 1 0. Okay, and we fill that from the state table. And what's the value of the output at each given combination? If I have the value of Z. Now, since it does not depend on W, so I'll have these two lines will be the same. The output does not depend on W. تمام. at state 0 0 the value of the output is 0. That means this will be 0 0. At 0 1 z equal to 0. So at y2 y1 equals 0 1, that's going to be zeros. And then at 1 1, this is don't care. And then at 1 0, I have 1, so this will be 1 1. Okay, so now z will equal to, from this came up, if you take this group, this will be the value of y2. So z is equal to y2. Similarly, make a K-map for capital Y1 and capital Y2. Now check, this is the one that we did. Z is equal to Y2. Actually here, they ignored the value of W before even creating the K-map. So you take, you fill the K-maps for Y1 and Y2, and then do the K-map minimization. You come up with Y1 will equal to W Y1 bar, Y2 bar, Y2 will be W or W and Y1 or Y2. So you come up with these equations, and then you draw the circuit. Now, if you have issues in what we have been doing so far, from this slide up to this slide here, this is completely CEN211. This is what we covered in chapter 4 in 211. So if you have any difficulties, you should go back and review the slides for 211 chapter 4. They will have more information about creating these circuits. And I think it was chapter 4 part 2. Chapter 4 part 1 was talking about latches and flip-flops. Chapter 4 part 2 is talking about sequential circuit design. The last part was talking about state machine, so you can ignore that. Anyways, once you come up to this circuit, now I have two flip-flops. This is flip-flop 1, flip-flop Y2, sorry, and this is flip-flop Y1. For example, if you want to check the values, let's say the next state equation for Y1 was W Y1 bar Y2 bar. So you take W, you take Y1 bar, which is coming from here, and you take Y2 bar, which is coming from here. Okay, this will give you the value of capital Y1. We used to call it D1, and this is D2, ولكن هنا حنسميها capital Y for the next state and small y for the current state. One thing important to note here, the output of the flip-flop is an input to your sequential circuit. And the input to your flip-flop is the output of your sequential circuit. هذه is the next state, and this is the present state. Okay, so remember, when we read the code, that's going to be very important to note. Capital Y is the next state and small y is the current state. طيب, since we have this timing diagram is just simulating the same example we had here. I think this is simulating this one. That's going to be easy to follow, so we'll jump to the code. Now this is the complete code for our finite state machine. There are three ways to write the code, and we will check each one of them. Usually you can do whatever you please, ولكن some people find one circuit makes more sense than the other, but we will cover them all. الآن قلنا في أي finite state machine عندنا combinational وعندنا flip-flops. You can do that in your Verilog code. We will make one always block for the combinational circuit and one always block for the behavior of the flip-flop. So let's come to our input and outputs. I have for my input, I have a clock input and I have reset input. These are mostly, usually in any finite state machine, you're going to have these two signals. And then I have one input W. For the outputs, I have one output, which is the value of Z. And then I'll make two rigs size 2 to 1, meaning I have Y and capital Y, so I'll have Y2, Y1, and I'll have capital Y. Sorry, I have Y2 and Y1, and I'll have capital Y2 and capital Y1. This is what's happening in here. It's like I'm creating wires for these values, these four values. Okay. Right. One thing that will make your life easier is to declare the states or the state codes in a parameter. ليش? Because when you code, you don't have to remember the actual binary code that you stated for each state. So I'll have 2-bit parameter A, B, and C, and I'll give it the code that I assigned them before. So A will be 0, 0, B will be 0, 1, and C will be 1, 0. Okay. I don't think that declaring the parameter 2 to 1 or 1 to 0 will make a difference here. If you make it parameter 1 to 0, meaning that this is a 2-bit parameter, or parameter 2 to 1, that will make any difference. I don't think it will. Anyways, it has to be 2-bit. So on 2, 1 or 1 to 0, it has to be 2-bit because you're assigning 2-bit for each state. Okay. Now you write the code for the combinational circuit. So for combinational circuit, we list the number of inputs. What is the input of my combinational circuit here? I have W and I have the value of Y2, small
Y2
Y2,
Y1.
Y2, Y1, the small one, small letters. Actually I hate that. يعني لو سموها D ودي كان أسهل. ولكن anyway, the small y's are going to be an input to the combinational circuit, so that's why you have it listed in your sensitivity list. Okay. Now go in your combinational circuit. We have two cases. Let me see how they did it here. Now we need to find values for the output of the combinational circuit. What are the outputs of your combinational circuit? That's going to be the value of Y2 and Y1. Okay. Here he used the case statement. Okay, let's go with it. الآن depending on y, طبعا y ايش هي؟ small y is the current state. Y is the current state. Now, the current state, I have three cases: A, B, and C. So this means case Y, so it will take, يعني Y will have one value of these three. So if I'm at state A, I need to check the value of W. If W equal 1, move from state A to state B. That means let the value of Y اللي هي عبارة عن Y2 Y1 equal to B اللي عرفناها هنا as 0 1. So Y1 will be 1 and Y2 will be 0. You can write this directly from your state table. So if W equal 1, go to B. If W equal to 0, stay at A. Okay. Remember, guys. Next state, current state. Now, at state B, if W equal 1, go to state C. If W equal to 0, go to state A. In state C, if W equal 1, stay at state C, because this is what we have in here. If you are at C and you get W equal to 1, stay at C. Else, go to state A, that means W equal to 0. Now, Y is 2-bit. تمام. فعندي 4 cases المفترض. I can add the default case, which will make the value of Y don't cares. Now this will finish, will end the description of the combinational circuit part. If you go to the sequential circuit part, that's going to be very easy to do. And actually, you don't need to change this code. If you are going to define a separate combinational block, a separate always block for the combinational circuit, and a separate combination and a circuit, or let me repeat that. If you're going to make a separate always block for your combinational circuit and a separate always block for your flip-flops, this block usually will not change, because what's happening here is very easy. Now, always at negative edge of reset in, that means I'm resetting. This is an asynchronous active low reset, as we covered, and or positive edge of clock. You go in, check for the reset. If the reset is active, make the value of the current state equal to state A. Now, remember that this has to be A. It's not 0 0. مو شرط يكون 0 0. It depends on how you reset your circuit. Now, if you reset here to state A وأعطيت A the value of 1 1, it doesn't mean that at reset you're going to set the value of the flip-flop to 0 0. Okay, so reset goes to your first state. عاد الكود اللي اعطيته ال A هذا شيء راجع لك. انت تعطي A اي كود you want. هنا حصلت انه احنا اعطينا A كود 0 0 from here, but you can give it any code. So when you reset, make sure you're resetting to the state, to the first state, not to 0 0. مو شرط يكون 0 0. تمام. So that's why in reset Y will takes on the value of state A. Okay, that means make the current state state A. Else, since I have my combinational circuit block is taking care of everything in here, يعني كل هذا already described in my combinational circuit block. So in the always statement taking care of the combinational circuit, this is all already taken care of. All I need to do for the flip-flops إنه y2 equal to y2. هنا y1 equal to y1. That's it. So I come in here, I say else, if I'm not resetting, just make my current state takes the value of the next state. Okay. And then one last thing is to assign a value for the output. So output Z is equal to state C, I think. If you go back here to your state table, you find that my output Z is equal to state C. So meaning if the current state is C, let Z equal to 1. That's what's happening in this assign statement. Assign Z to Y equal C. That means if the current state is C, make Z equal to 1. Okay, so we broken a finite state machine into 3 parts. The combination circuit, this is the one that requires some work to read from the state table and to read from the state diagram and make sure that your logic is working fine. بالنسبة للsequential block, it's very easy to do. If you are resetting, make sure you are going to whatever state you defined in your state table or in your state diagram. And if you're not resetting, just let the value of the current state equal to the next state. Third part, assign the value or assign the value of the output. Okay. there are two more ways to write الكود. تمام. We'll check them inshallah next class. Um, but for now we have to stop because we are out of time. طيب. Any questions?